Good morning and welcome to the class. So we are going to study about plate tectonics. Okay. So let's start with the plate tectonic. First of all, this theory is about what it talks about. So this is going to answer the formation of the continents. In the topic formation of the continents, we study about continental drift theory, plate tectonics, and we get the answer how the continents are formed. Now, as the first theory is about continental drift theory, जिसने हमें ये तो definitely बताया कि continents move from one place to another, but he could not answer Mr. Alfred Wegener that why it moved. The refined theory and important is plate tectonics. So in this one, comprehensively we can understand the reason behind the plate movement, formation of the continents, and so. So let's see, and in this we are going to study the plate movements specifically. So plate tectonic, what is a plate first of all? Here we describe the rigid lithospheric slabs or the crust of the earth as plate. The rigid lithospheric slabs as plates. This is scientifically we can understand the interaction. Now for this theory, it has taken inspiration from the other. First one is continental drift, जिससे हमें ये पता चलता है कि this continents move away from each other and led to the formation of different things. Also with these two important theories which answer the real question that why continents move, that is convection current theory and seafloor spreading. So with this we understand the formation. Now quickly let us see this one as a first is convection current theory. Continental drift theory, what it talks about, this one. So how was it? The continental drift theory, it talks about this phenomenon that it was divided into two parts, Pangaea and Panthelus. Okay, so that Pangaea broke into different parts like this as Laurasia and Gondwana land. Gondwana land further broke into the different small continents like South America, Africa, India, and later North America, Asia. This thing as per the continental drift theory, and we could see the today we can see it. Formation, right? So this is continental drift theory. However, and different evidences we had seen. However, there were some criticisms. The criticism that Alfred Wegener could not explain why. So topic for today is plate tectonic. That is more refined one, and that's what we will see. So plate tectonics divide these into small lithospheric slabs as plates. There are 7 major and 20 minor plates. Okay, major plates like Eurasian plate, Indian, Australian, American, Pacific, African, and Antarctic, and a few minor plates. Okay, now this plate interaction is going to tell, but still let us answer the first question: why the continents move? First of all, Alfred Wegener was not having the clear understanding of internal structure of the earth. That he couldn't understand, such a strong force is not outside the earth but inside. He thought that gravitational pull of sun and moon was enough to pull up, or the pole fleeing force, or other thing, but all those things were based on assumptions and not accurate, and hence the more refined theory we are going to study. So what is this? So these are the plates and how we understand. So actually what answered why the continents move? Why these continents move? Okay, and that is we understand by convection current theories. Yes. So let's have a look at it. Convection current. So after the criticism, we come to know about convection. We know that this is the internal structure of the earth: core, mantle, crust. Okay, core, mantle, crust. This brown colored small thin layer, which is just 1% of the earth's interior, is the crust. This is the convection inside the mantle. Okay. These are the convection currents due to the temperature difference in the mantle. Now they are so strong that they are able to move the plates. They help in the movement of the plates or the crust. This convection currents, this seismic energy, when it rises up in the form of volcanic eruption or so, it broke the land surface, a slab, into two parts, and as these, the convection currents are the drivers of the crust. जैसे जैसे ये currents जाएंगे वैसे वैसे this crust will move. Okay, so it will rise, it will go up, and यहाँ subduction होगा, जहाँ subduction इस तरह से होगा. So main thing, what is the reason? Convection currents. It is that strong for this thing. So from the convection current, we could understand that this is because of the one convection currents. So where do we see this proof? So first of all, what happens? This is a lithospheric slab, any slab. Now, because of the convection currents, whenever this seismic energy comes up, this breaks into two parts and the continents move away from each other. First of all, they move away. Automatically, that place is filled up by water, and this a sea floor is created. So right now, this is the sea surface and this is the new sea floor. Now whatever happens inside, see, still the volcanic eruption is taking place, the lava. Okay. Now whenever this lava, it cools down, a new crust is created. So what we have observed, first the division of it into two parts, then this starts moving away from each other because these convection currents are the drivers. जैसे जैसे ये current जाएंगे, ये old crust भी जाएगा. At other point we have observed there are the points where it subducts and we call it as subduction zone. जहाँ ये जो arrows है like convection currents नीचे जाते हैं, वहाँ subduction दिखाई देता है inside the sea floor. Now, in the same time, due to this volcanic eruption, a new floor is created. So actually what is taking place is whatever the sea floor is expanding and we call it as sea floor spreading. This somewhere proves the existence like this. So this is a rise of magma as lava and a new floor. This is a new crust which is created. This is the old crust. This old crust subducts at these points, subduct at some other points. So this is the rise and a chain of mountain, symmetrical chain of mountain is created. So this way sea floor spreading takes place. So wherever these are subducting, trenches are formed in the sea. So somewhere sea floor spreading is the evidence of this activity inside the earth's crust and resulting into the plate movements. So this how it looks like. First of all, rise of the energy, division of the crust. Because of volcano, new floor is created in a symmetrical form and old crust is moving away. How and what is driving it? These currents are the driving force. जैसे वो जाएंगे, similar way the crust will also move. जिस point पे subduct होंगे, even the crust will subduct. And here, the V-shaped deep trenches are the outcome. This is seen. Somewhere it looks like this. A very clear view of it. Okay. So we'll just say it's a very clear image how it is happening. We see these are the points. यहाँ से that the slab plate broke. Division started. It is moving away. Rise of the volcanic one. Okay, new floor is created and at this point it is subducting. So this is the subduction zone. Subduction zone. Very nice view of it we can see here. So and we have observed this happening. For example, in the Atlantic Ocean, some chain of mountains are formed and as it lies inside exactly in the middle, so we call it as mid-oceanic ridge, that is mid-Atlantic ridge. Okay? So this we can see a very clear image. So basically plate tectonics talk about all this, make use of this theory, make use of all this theory to see and explain the one. Okay. Now we will see how it is happening. Another part. So in the plate tectonics, we have seen another part, plate movements, movement of the plates. So this was the plate tectonic, but how it is happening, this we can understand from the plate movements. That is movement of the plates. There are three plate movements. One is convergence, divergence, and transform. So basically these plate movements lead to the formation. Whatever we have seen right now, that was divergence. So what is convergence? It is also known as destructive plate boundaries or the So there was a convergence, destructive plate boundaries. Let us see convergence. So what is happening in convergence is when two plates are coming towards each other, it is known as convergence. Two plates are moving towards. What is divergence is when a single slab breaks into two parts and move away from each other. Divergence is also known as a constructive plate. Okay, this is destructive, and transform is a conservative where neither the crust is created nor destroyed. Okay, where it breaks into two parts and they are moving parallel to each other. San Andreas fault is a common example which we can see over here. So simple example first we will see. This is the conservative or transform when plates are moving away. So one of the phenomenon is when plates are moving parallel to each other, a fault is created. For example, San Andreas fault, a typical example where crust neither is created nor destroyed. Very, very important are the other two phenomenon, that is convergence and divergence. In this class, we are going to discuss about convergence. Very important and responsible for important phenomenon, convergence. So convergence, the literal meaning is collision. I always call it as an accident. When two bodies exactly in front of it, the only outcome is convergence, destruction and thing. Now, before this convergence, let us quickly revise. We know that Earth's crust is made up of two. It is classified into two types, that is oceanic crust and continental crust. So whatever is going to happen is going to happen between two. So thus there are three possibilities of convergence. Either it will be these two plates where they are moving towards each other. What are the possibilities we'll see. So in convergence we know that two plates either they move towards each other. Okay, plates are moving towards each other. Now there are three possibilities. These two plates can be either oceanic plate and continental, or it can be continental or oceanic and continental. These are the moves. Now first of all, when it is both of them are oceanic and oceanic, both the plates are oceanic. We know that the property of oceanic plate is it is heavier, it is denser as compared to the continental one. So whenever two oceanic plates are moving, both of them will try to subduct. Okay, so whenever oceanic, as it is denser, always the oceanic plate will subduct because of being heavy, and it gives rise to the volcanic eruption. So let's understand one important phenomenon. Wherever there is oceanic plate, it subducts and it gives rise to volcano. So जहाँ जहाँ subduction होगा वहाँ वहाँ volcano होगा. Okay, so now in both of them will try to subduct, and that is why here fold mountains are not formed. What is the outcome is volcanic eruption. Even the group of islands are formed. Islands, volcanic eruption, volcanic islands, and earthquakes. So wherever volcanoes are there, earthquakes definitely follow. Next is oceanic and continental. Now when one of the plate is continental, what is the outcome? This is the continent. Okay. Now this oceanic is heavier. Whenever only this will try to subduct. Now whenever this is heavier, denser, this oceanic plate will subduct and give a thrust to the continental. Outcome is this continental plate, it rises, overrides the oceanic, giving rise to the fold mountains. So the addition over here is rise of fold mountains. So दुनिया के सारे फोल्ड माउंटेन्स ऐसे ही एजेस पे बने हैं, जैसे कि नाजका, the Andes where Nazcan is oceanic crust, ठीक है, oceanic plate and continental crust. See, these are the examples. Now this is what Andes, this is oceanic plate, oceanic convergence, and this is continental. So the outcome is oceanic and continental. The outcome is fold mountain. So दुनिया के fold mountain ऐसे ही बने हैं. It overrides fold mountains, earthquakes and volcanoes are the outcome. Okay, so now addition is fold mountains. Now the last possibility we will understand over here, both of them are continental. Now when both of them are continental and continental, none of them will subduct. Not so. Hardly there is some difference of density. Okay? So both of them will override and rise. They try to rise as a fold mountains. So when both of them are continental, it will just uplift because there is no subduction. Very less. Very less. Hardly a some. That's why they collide, give rise to tallest mountains in the world, that is Himalayas. So in the last possibility, the last point for today, the last point is continental convergence. What do we see as the plates move towards each other and the outcome is the formation of the fold mountains. An example is Indian plate. Indian plate collided with Eurasian plate and the result is the tallest mountains as Himalaya. So all this I have mentioned in the notes here. This is a continental convergence. Okay. So this is the third and the final one to understand plate tectonics. So these actually prove the way continents are formed and the real reason for this. I hope you understood the class. You can ask all the doubts. Thank you.